Okay, quick review. Put all your phones and iPods and all that stuff away. All right, so how do we divide these?
Very good.
You use the internet.
Hey, yeah, we can use synthetic division here, can't we? Sometimes we're stuck doing long division, but when we can, synthetic division is much easier. Remember, we can use synthetic division whenever we can divide some polynomial by something that looks like x minus k. Now, k could be a positive or a negative number, right? But if we could write it in that form, then we can do synthetic division. So we can here, can't we? What's k? 6. Okay, this works. This works for us to do synthetic division if k equals 6. Now, what do we end up with? How do we do that? How do we do the synthetic process?
You make an L.
Okay, I make my bracket.
You put the 6 on the left-hand side of the vertical line.
Okay, good. So the value of k goes out front. So that's an easy way to find k if you're doing division is just to set the denominator equal to 0 and solve for x. And that's going to give you back k. It's the 0 of the denominator. So we get a 6 right there. What are my coefficients?
1, 0, and -10.
0, -10. Anything else?
There's 0.
Another 0. How come?
Because there's
There's no constant, and we need to have a constant. Good. So remember what the rule is. We need to include zeros for every missing term in this polynomial, right? Now, how many missing terms are there? Well, we're missing the x squared term and the constant. You can always do a quick check to see if you have the right number of coefficients written down when you're doing synthetic division by just adding 1 to the degree of the polynomial, right? So if it's a cubic polynomial, you're going to have 4 coefficients, 1 for each power of x plus the constant, right? Okay, what else do I need before I start? There's one other piece of this bracket I'm missing.
The square box.
Okay, the remainder box. Good. All right. And then what do we get?
So drop down to 1.
Okay.
answer is going to be 0.
In here?
Because the last number is a 0.
Oh, maybe. We'll see. So we'll see. That's
Multiply with 0.
okay. But remember, we're adding something into there, though. We'll just see. Let's see what happens. Whenever I get a number down here, I multiply by k. So 1 times 6 is 6. If I add 0 and 6, I get 6 times 6.
36.
Add
26.
That's embarrassing.
No, it's not. That's not embarrassing.
Yeah,
Okay, so 6 times 26 is 156.
Something like that.
Go for it.
And then that's 156. Is the
Okay,
remainder.
and then my remainder is 156. Okay, so then, what's my answer?
Squared,
How'd you get that, Kevin?
because there's only 3 numbers.
Okay, good, exactly. And so that's got to be the constant. That's got to be the coefficient of x. That's got to be the coefficient of x squared. And if there were more numbers, we'd get x cubed, the coefficient of x to the 4th, etc. But it stops at x squared. So these are the coefficients. So we get back 1x squared. We wouldn't write the 1 though. We never write a coefficient of 1 plus 6x plus 26. Now, how do we write the fractional part of our answer?
156 over x minus 6.
Good. So we have to add to that our remainder of 156 divided by our denominator. Remember, the remainder is how much is left over the denominator, right? And that's it. Okay? Make sense? Okay, let's try another one of these. Quick practice. Whoops. Forgot what I'm dividing that by. Let's see, I think we're dividing that by... I better look and see, I can't remember. I erased too much. -2. Okay, so we're dividing it by... So how do I set this up with a synthetic bracket then?
Put -3 on
Okay, so I'm gonna make my bracket, and then what's k?
Negative 2.
-2. So -2 goes out here.
Which is opposite.
1.
Yeah, it's right, it's always, there's two ways to think of it. If we write the denominator in the form x minus k, then what would k be? So this is x plus 2, so it'd be x minus -2. Maybe the easier way is to just set the denominator equal to 0 and solve. Right, so if I set x plus 2 equal to 0, x equals -2. So that's k. Okay, so what are my coefficients?
1, -5, -2, and 4.
Okay, we'll probably need that whole thing. So let's see, if I bring down the 1 times -2 is -2. What do I get here?
-7,
Okay. 14.
12, -24, and that's 0.
Okay, so if the remainder is 0, do I even have to write the fraction part? I don't, do I? In that last problem, we got a number in our remainder, but if that had been 0, 0 divided by anything other than 0 is 0. Yeah, we wouldn't even write it then, would we? So this time our answer is what?
X squared minus 7x plus 12.
Okay, how about that? Yes?
You said 0 divided by anything. What is 0 divided by 0?
0 divided, good question. 0 divided by 0 is what we call an indeterminate form. So it could be anything, and it depends on how you're getting those zeros. So that's something, when you get to calculus, we'll talk about that. How do we resolve indeterminate forms? Yes?
Is it the same like 0 to the 0 power?
Yes, 0 to the 0 power is also indeterminate. And there's some other indeterminate forms are, what is 0 times infinity?
Infinity.
No, it's indeterminate. Depending on how you got the 0 and how you got the infinity, it could be anything. So, once again, we could spend a whole year, I could just talk about nothing more than those 3 problems, and we'd have plenty to talk about, I promise you. There's a lot of math that goes into that stuff. Okay, but we won't do that. So, this is our answer, but now I want you to see something here. This is a really key relationship right here. So we found that when we divided our original polynomial by x plus 2, we got that answer, right? Isn't that the same thing? I'm going to make this red just so we can kind of color code things so we can track what we're doing. Isn't that top equation up here? So this equation in the pink box, isn't that equivalent to saying this? Is it? It is, isn't it? Right? Everybody see that? What did I do to get from here down to there? To this bottom equation?
Multiplied x plus 2 to both sides.
Yeah. Everybody see that? All I did is multiply both sides by the quantity x plus 2. So that x plus 2 went away. Another way of thinking about it is, I could cross multiply, right? Everybody see that? Because anything, if there's no denominator, the implied denominator is 1. So I could just cross multiply. The numerator of this side times 1 equals the red denominator times the blue numerator, right? Okay. That's pretty useful. Because it turns out then that division is actually a helpful aid in factoring. In fact, really, you could say, in fact, you'd be right in saying that factoring is the same thing as dividing. When you factor something, you're just dividing it out of something else, breaking it apart. Okay, so if we were, for example, given the original equation that we started with, let's just say we were given this polynomial up here, and we were told that x plus 2 is one of the factors of that. Find the others. How would we do that? Well, kind of we started doing that already, didn't we? If we were told, let's take an example with numbers. Let's say I gave you the number 132, and I said that 11 is one factor of that. Find the other one. What would you do? Divide it by 11, wouldn't you? Wouldn't you divide this by 11 to get what answer? No? 12. Right? So 132 would just equal 12 times 11. We had it factored into two smaller factors, right? We're doing the same thing here, aren't we? If I told you that x plus 2 was one factor of this, you could divide it out and find the other factor, right? Now, could we keep going? Well, yeah, in this case, maybe we could. Remember, if we're supposed to completely factor something, and I'm going to have you do that on the assignment. I'm going to tell you to completely factor some stuff. So then we have to keep factoring until we can't factor anymore. We've got to break it into pieces until we can no longer break it into pieces. What about the red part? Can we factor that any further? No, we can't. It's linear, right? The biggest power of x is 1. We're done. And I can't take out a greatest common factor, right? What about the blue one?
Yes.
Maybe. It's quadratic, right? So there's a chance we could factor this. Now think back to chapter 5. I'm not really going to ask you to do a lot of the ugly a times c then split b factoring. But I am going to ask you to do some of the simple when a equals 1 kind of factoring. For a quadratic expression, when a equals 1, factoring either works or it doesn't, but it's simple. How would this break down if it does factor? What's the template going to look like? If a is 1, so the x squared is by itself. It would have to unfoil, so the first term of each factor was what? X. And then all we need are magic numbers. They should multiply to what and add to what. Be careful.
Negative 5 and
Negative 1
Negative 4.
Okay, good, because Jody, they have to always multiply to what and add to what?
12 and add to 4.
Okay, they're going to multiply to the constant and add to b, right? Okay. So yeah, the numbers would just be negative 3 and negative 4. And then don't forget that we also have this other factor that we were given, right? Make sense? So we could use the fact, in this case, that we were given one factor to divide that one out and find the other ones. What made it simple here is that when we divided the original expression by x plus 2, we were left with a quadratic factor. Quadratic factors are much easier to work with than cubic factors. They're smaller, right? Okay, so let's do another problem sort of like that, but disguised. Here's the other kind of problem that you're going to be given. Stuff like this, where I'm going to tell you to factor f of x, given that, so that's just a semicolon. Don't confuse that for being anything important. I'm just trying to separate these two statements. Given that f of 6 equals 0. Okay, now why is that important? What is that really saying? I want you to take this statement up here and be a little more specific. What key information am I giving you?
X equals 6.
Okay, x equals 6. What does the x value of 6 do?
Gives us k.
That's k, isn't it? K is 6 in this case. But why? Okay, because wouldn't you agree that 6 is what we would call a 0 of the function? The meaning of a 0 of the function is if I plug that value in for x, I'm getting back 0 for y. Everybody agree? Now graphically, what does that mean? If I were to graph the function and look at that point that had coordinates x equals 6, y equals 0, what kind of special point would that be? Say it again.
P.
An intercept? What kind?
X-intercept.
X-intercept. Because y is 0, so it's got to be on the x-axis, right? So that's an x-intercept. So zeros of functions are x-intercepts if they're not imaginary, right? But that, in terms of the graph, that's what they would be. All right? So the 0 is 6. Now here's a relationship that's always going to be true. if k is a 0, so if f of k equals 0, then x minus k is a factor of the function every time. Okay? So the fact that we're told that 6 is a 0 is really just like that last problem where we were given a factor, isn't it? Right? We were able to divide the black expression by x plus 2. We did it synthetically, but that gave us back a smaller factor, right, that we could break apart. This time, what factor are we being given? If we're told that f of 6 equals 0, what's the factor we're being given? Well, here's the rule. If f of k equals 0, so k is some number that's a 0 of our function, like 6, then x minus that number is the factor that goes with it. There's always that relationship. If we know a 0, we know a factor, and vice versa. Okay? So what's the factor this time?
X intercept.
Well, yeah, but what is it? It's x minus 6. That's it, right? So we know then, we know in this case that this function is going to break up into, whoops, we know that x cubed minus 3x squared minus 16x minus 12 is going to equal, let's make this red, x minus 6 times something else. Call it, I don't know what we're going to call it. Let's call it f for factor. Right? We don't know what it is yet. How would we find out? Divide. That's it, right? I could divide the polynomial by x minus 6, but I could do that synthetically, right? Okay, is that making sense, what I'm saying there? Right? So to find out what f is, oops, f is just equal to this, oops, it's cubed minus 3x. Right? Everybody agree? Just dividing both sides by x minus 6 to find out what that is, to isolate it. So let's do that synthetically. What goes out front? 6. What are my coefficients? 1. Okay. Anything else we know before we start? Yeah, there's something. What goes in the box? 0. How come?
Because there's 0 there.
Because, yeah, because that's a 0, right? Think what this synthetic division, before we even knew it was synthetic division, remember the trick that we played. Earlier in the unit, we called it synthetic substitution, and we said if I want to know what the value of f of 6 is, all I have to do is plug 6 into my function synthetically. Whatever's in the answer box is the value of the function, right? Well, I know what it is. I'm told that it's 0, right? So if 6 is a 0, the remainder has to be 0, which also means, doesn't that also mean then that x minus 6 is a factor because it must divide in evenly with no remainder? All goes together, doesn't it? Yeah, how about that? So what do we get then? What happens if I don't get a 0 there when I do the synthetic division?
You did it wrong.
I did it wrong. I better try it again because it has to be 0. So if I bring the 1 down, I mean it would mean there's a remainder, right? But there can't be a remainder, right? We're told that there's not. So 1 times 6 is 6. What do I get? 3, 18. What goes there? 2, 12, and it works. I get 0. Okay, so then what is f?
X squared plus 3x plus 2.
So I can go back up here and I can replace that f. That's the factor, right, that goes there. Everybody see that? That's what the synthetic division did for us. We were given the 0 of 6, so we can divide out the factor that goes with it synthetically, and that's what's left over. That must be the other factor then, right? So now all I have to do is go further if I can. Oh, it's too big. Okay, can we go further?
Yes.
What do we get?
X plus 1 minus 2.
Yeah, the magic numbers that work here that multiply to 2 and add to 3 are x plus 2 and x plus 1, and that's it. We got a factor. How about that? Okay. All right, now, that's one of the kinds of problems that I'm going to ask you to do. There's two main problems. That's one of them. I'm going to give you a 0. I'm going to ask you to use that information, 0 of a polynomial. I'm going to ask you to use that information to completely factor the polynomial, which we just did. Okay, the other thing I'm going to ask you to do is actually a little bit easier, but probably more important. It's something very much like that. I'm going to give you a polynomial. I'm going to give you a 0 of that polynomial. And I'm going to ask you to find all the other zeros. Now let's go back to the last problem for a second. And let's talk about why that would have made that last problem just a little bit easier. If all I was trying to do was find the zeros, then that means I'm really just trying to find out when, I'm really just trying to find out when the function equals 0. Now remember why it is that we factor in the first place. The whole reason that we ever factor anything is because we want to be able to solve big equations. I start off with this equation that's too big to solve. I've got this big expression, this big expression on the left side. Oh, I'm going the wrong way. This is equal to 0, but I can't solve that. It's cubic. There is no silver bullet there. There is no cubic equation where I can just plug in numbers and get answers. I have to break it apart into smaller pieces so that I can trade this one big equation for a product of smaller factors that's equal to 0. By the 0 product property, we know that the only way that the red factor times the blue factor can equal 0 is if what? The red factor is 0 or the blue factor is 0, right? Remember that trick we've been using for a long time now. The only way a product can equal 0 is when you multiply by 0. So there's going to be a case where whatever value of x makes the red one 0 would work, whatever value of x or whatever values of x make the blue factor 0 would also make the product 0. So then we don't even really need to factor that any further, do we? We could, but we don't have to. If I do factor it further, I get 3 even simpler equations that I could set equal to 0 and solve. What's going to be the answer to the first one? If I set x minus 6 equal to 0 and solve, I get 6. Okay, that was the one I already knew anyway though, right? If I set x plus 2 equal to 0 and solve, what do I get? Negative 2. If I set positive 1 equal to 0 and solve, or x plus 1, I get, okay, so I could do it that way, but I didn't have to factor. I could have just stopped back here. Could have bailed off the factoring train after one step, and instead got my 6 and set this factor equal to 0. And solved a different way. How? How do we can factor, in this case factoring really was probably the easiest way this time, because it was such an easy thing to factor. But what if it had been a harder problem to factor? How can we always skip factoring? If I have a quadratic equation in standard form like this, quadratic formula, sure. X equals negative b. A is 1, B is 3, C is 2. Plug it in, get your answers, right? So in this case, maybe that wasn't even any better. Factoring was easy enough. But this time, let's see what happens. So if I'm given 1, 0, What am I gonna do next to find the other ones? If I'm given a 0, that means I'm also given a factor. What's the factor? X minus 8. And so that's important because I could divide my cubic polynomial by x minus 8 to find out what the other factor is, right? That make sense? Okay, so let's do that. We can do that synthetically. What goes out front? 8. My coefficients are 15, negative 119, negative 10, 16. Do I know what goes in there? 0. Good. And so we end up with 15, 8 times 15, 120. So what goes down here? 1. 8, so negative 2. It worked, right? Okay. So then I know that my polynomial 15x cubed minus 119x squared minus 10x plus 16 breaks up into x minus 8 times what?
15x squared.
Ah, okay. Plus x minus 2, right? Those are the coefficients. Okay, and my whole goal is just to find out when that equals 0, right? When this whole product equals 0. Well, one of the zeros is 8, right? The other one is the one that we're going to get. If we set these equal to 0 and apply the 0 product property, we get 8, or we get the quadratic equation in standard form. 15x squared plus x minus 2 equals 0. What's a, b, and c there? Because we're not going to want to factor that one, are we? No, no way. Because a is not equal to 1. So it makes it hard to factor. That's a times c, then split b, and that's long and difficult. So what's a? 15. What's b? 1. What's c? Negative 2, and all we're going to use is the quadratic formula. Okay? Just plug those numbers in. But did we even need to write this step out? We already knew, didn't we, that 8 was a 0, so this one was already accounted for. We didn't even need it, right? We didn't need to write that as a factor. Do you see the values of a, b, and c somewhere else? The 15, 1, and negative 2? Ah, yeah, we do. Look right here. Okay, look at that. If we know those are the coefficients of the other factor, well, we know that's got to be the constant, which is c. We know that's got to be the coefficient of x, which is b. And we know that's got to be the coefficient of x squared, which is a. So if those numbers are ugly, if a is not equal to 1, there's no need to even go down here and put this into a factor, is there? What should we do instead, probably? Plug it into the quadratic formula. Just go straight from here into the quadratic formula. X equals negative b, so negative 1, plus or minus the square root of b squared, which is just 1, right? Minus 4 times 15 times negative 2, all divided by what? Yeah, 2 times 15, 2 times a, so 30. Okay? And if we simplify that, what do we get? Negative 1 plus or minus. Now I've got 2 negatives multiplied together, so we're going to be adding, right? So I've got 1 plus 60 times 2, so that's supposed to be a 4, isn't it? I think I messed something up here. No, I guess I did it right. C 70. Oh, 1. What did I do? That's 4AC. Oh, I put B down, not A. Oh, I did. What did I do wrong? Yeah, but it's squared.
480.
AC. Nothing's wrong. Nothing's wrong. Okay.
Is it supposed to be?
Oh, it's one. Never mind. It's right. That's 120 plus 1 is 121. Right? Everybody see that? I knew it had to be perfect square, and I just couldn't figure out what was going wrong. So what is the square root of 121? So let's figure out what these answers are then. If I take the plus version, if I take the plus sign from the quadratic formula, I'm getting -1 plus 11 over 30 is what? 10 over 30? Right? And that's what x is equal to. So x equals 1/3, right? What if I take the minus sign? Then I'm going to get x equals -1 minus 11 over 30, which is -12 over 30. So what's that reduced to? 6 goes into both those. 2/5, -2/5. So what are my zeros then? If I had to write out a list like you will in Moodle, 1/3, -2/5, and 8. Okay, make sense? Got it. Okay. Okay, I'll skip that one. Okay, here's the last one I want to do. So what about this guy now? This is a good one. I'm going to show you something tricky here. We're supposed to write an expression for the missing dimension in terms of x. Okay, so we have a rectangular prism here. How do you find the volume of a rectangular prism? Length times width times height. Good. Well, we know the width and we know the length, but we don't know the height, do we? Okay, so let's just call that h. How about? Okay, so how am I going to write out an expression to solve for h? For an equation to solve for h. Because think about this, what I've really got to do here, if I want to solve for h, I have to be able to write an equation that has an h in it so I can isolate h. Right? That's how we solve for something, is we isolate it algebraically. So what's the relationship there that involves an h? Here's the volume. What do you think, Dylan? There's the volume.
X plus 10 times x plus 6 times h.
Okay.
X cubed.
Good. Good, good. So the volume equals the length of x plus 10 times the width of x plus 6 times h. Right? Okay, so now we end up with an equation there that we can use. Polynomials work just like variables and numbers, right? We know how to add, subtract, multiply, and divide polynomials. So how am I going to get that h by itself? What are my strategies here? Got to get everything to the other side. Well, how am I going to get rid of the x plus 10 and the x plus 6? Divide. Now I have two options here, don't I? I have the option of either multiplying, foiling these out, which I could do. I could FOIL those out, and if I did, I'm going to get, let's see, if I do FOIL those out, I get the equation x squared plus 20, or x cubed, plus 22x squared plus 156x plus 360 equals. If I FOIL those out, I just get what? X squared plus 6x plus 10x is plus 16x plus 60 all times h. And the advantage is, how many times do I have to divide now? One time, right? Okay, what's the disadvantage? When I divide both sides by x squared plus 16x plus 60, what's wrong with that?
We don't have a 0 to divide.
I don't, okay, meaning what? What can I not do this time that I've been able to do in the past? What?
Yep.
Synthetic division, right? Because I've got an x squared on the bottom then. Long division, you tell me which is easier, synthetic division or long division? Long division is easier? You're a masochist. Long division is harder. Definitely. So now, maybe it's worth it sometimes, but this time I'd say it's probably not, because I can use synthetic division. Sure, I have to do it twice, but it's a lot easier to do, isn't it? Right? So let's see what we get. If I want to divide, let's first divide by x plus 10. We'll make that one blue. So we'll just kind of track this progress here. So if I'm going to divide my original polynomial, divide the left side, what are the coefficients of the polynomial on the left? 1, 22, 156, 360. What's the 0 that goes with that factor? Negative 10. Does everybody see that? And what has to go in the remainder box? 0, because it is a factor. So it should have no remainder, right? Okay. Negative 10 is a 0. So when I do this process here, I get a 1, a negative 10, a 12, what, a negative 120? If I add those up, what do I get? 36 times negative 10, negative 360, and they cancel. So it worked. Okay, so if I divide away the x plus 10, then what I would get, and you tell me if I even need to write this here in a second, what I would get is that x squared plus 12x plus 36 equals, let's make this one green, x plus 6 times h. Now what do I get? Divide by x plus 6, okay? But I didn't even need to write this down, did I? This is what I like to call nested synthetic division. I'm sure other people do this too, but I've just never seen this anywhere. It's kind of a cool little trick. Look what I can do. I can just take those coefficients, because that's after all what I end up with on the other side, and just do it again. Only this time, what's the 0 that I put out front? Negative 6, right? I didn't have to write that step down at all. I just know that when I divide that one away, whatever I'm left with, I just divide by that one, right? What goes in the remainder box? 0, because I know that negative 6 is a 0, because x plus 6 is a factor. And what do I get? Let's see, I bring down the 1 times negative 6, if I add them up, 6, negative 36, and it works. And so when I divide both sides by x plus 6, I get h, and what is it?
X plus 6.
Yeah, that's the constant, and that's the coefficient of x, so I just get x plus 6. How about that? So my other 0 then is what?
0.
Well, if I set, this is the other factor, if I set that equal to 0, what's my other 0?
Negative 6.
Negative 6. So if I write all my zeros down, what do I get? I get, yeah, good. I get negative 6, negative 10, and negative 6. Right? But that's not what it asked for, is it? It just wanted to know what's the other dimension. The missing dimension would have been this, wouldn't it? X plus 6. Okay, make sense? All right. Now, I'm not going to do this one, but could I use synthetic division here?
Yes.
Could I? No, how come? Yeah, the 15x minus 4, that doesn't look like x minus k, does it? There actually is a way you can make synthetic division work here, but it's probably not worth it. It'd be better just to use long division. And this is one where we would probably want to just multiply those two together and get a quadratic factor. So this is one where we'd want to do this. This is one where we'd want to do, and we won't go through it, but if we did, we would set the volume 450 x cubed to. If I multiply these two things together, we're just gonna get, oh boy, 90 x squared, oh boy, plus 120 minus 24, so 96x minus 32 times h. So I would just divide the black cubic polynomial by the blue quadratic polynomial using long division, and that's going to give me h. Right? Make sense? Wow. 9 or